Good afternoon, Sahi. So, starting with the today's class, this is all about muscles. So, starting with the introduction, you all know what muscles are. Muscles are basically soft tissues of your body, and they are the crucial parts of your musculoskeletal system. And if there are no muscles, you know that you can't produce force, and if you can't produce force, you cannot do movements at joints, and you cannot do movement at all. So, muscles are very important part of your musculoskeletal system and overall for your game, because muscles are the only way to produce force in human system. So that's why they are very important. And we have some principles, as whole body moves according to your biomechanical laws. Similarly, muscles are also having effects if we don't use it correctly, or there is biomechanics involved in muscles, like different structure composition of muscles varies the biomechanical properties of different muscles, because there are many muscles in our body, and these muscles are vary in their composition of connective tissue. कनेक्टिव टिश्यू कौन सा होता है जो कनेक्ट करता है मसल फाइबर्स को. So there is variation in different kind of muscles. So according to these variations, biomechanical properties of the muscles get different. So all these studies are involved in biomechanics of muscles. So how these composition affects biomechanical characteristics of muscles, that we are going to study. Because muscle, you all know in your diploma classes कहाँ पर कितने muscles होते हैं, that is the knowledge you should have already, and you can consult many apps. 3D motion lab, just आपको, if you have no idea about what muscle is there, so you can have idea from there. So you must know which muscles is where. So this is just an practice, you keep on reading, you learn, keep on learning. But in this class, in the at master level, you are going to study the biomechanics of muscles, how different composition of muscles affect biomechanical properties, what are these properties, how they affect the motion. So all these we are studying in different parts. So second point, muscle cell, what it contains. Basically, muscle cell basically contains protein filaments, actin and myosin. So these are the basic filaments which will actually uh, produce contraction in your muscles. These are arranged in the form of sarcomeres. A brief introduction before studying. You all must be knowing. अगर आपको नहीं मालूम, so I am just letting you know. So the basic functional unit of muscle is sarcomere, जो सबसे छोटा functional, जहाँ पर actual में contraction होती है, and that sarcomere is consist of this actin and myosin filaments. These are protein filaments. They slide over each other टू कॉज कॉन्ट्रैक्शन. जब सार्कोमेर कॉन्ट्रैक्ट करती है, देन मसल मायोफिब्रिल कॉन्ट्रैक्ट करती है. जब मायोफिब्रिल कॉन्ट्रैक्ट करती है, देन मसल फाइबर कॉन्ट्रैक्ट्स. व्हेन मसल फाइबर कॉन्ट्रैक्ट्स, योर होल मसल कॉन्ट्रैक्ट्स. सो दिस इज द वे the muscle anatomy is. I'll discuss with figures in the later section. So this is the basic unit. Then muscle functions to produce force and motion. So this is the biomechanical function of, you can say. So what is the biomechanical function of muscles? To produce force and thereby motion. And there are more than 600 muscles present in our musculoskeletal system, which will be involved in different skilled movements in your sports. Skilled movements कौन सी थी, इसमें आपको कोई skill पता लगता है, जैसे आप you are throwing a ball, you are throwing a javelin, it is a skill you have learned, and that skill many muscles are involved. Okay. And they produce energy for sport specific competition. Depending on your competition, depending on your game, you train your muscles accordingly. You make coordination of your muscular system with your nervous system accordingly, depending on your game. So all these are training aspects which will train your muscles as well as your other systems, so that every system in your body get coordinated and you execute a particular movement in a very efficient way. So this was just a brief introduction. Now coming to the next slide, some other key functions of muscles. So muscle maintain posture and body position. So when you are sitting or you are attaining some posture. So in that posture, though you are not making any movement, still muscles are working. Which muscles are working? Your stabilizer muscles, your trunk muscles, your glute. The glutes helps you to stand still. So there are muscles involved when you are standing still. So they are active just for standing as well as to stabilize your spine when you are lifting heavy objects. So when you are lifting some object, then some muscles are involved. So muscles are there in each and every movement, and they are doing their roles depending upon the type of movement you are performing. Even if you are not performing any movement, you are just standing, then for stabilization के लिए भी these muscles are working. Third important physiological point is they maintain your body temperature. Yes, muscles maintain your body temperature. How they maintain? Basically, whenever you do some muscle contraction movement, whenever you are doing any movement, that will produce an energy, and some amount of energies of that get converted into heat, and this heat keeps your body temperature within the physiological limits for the normal functioning. So this is must. So you should always have some this kind of function. Always keep remember. In addition to movements and the force production, these functions are also associated with muscles. So you always keep these points in mind. Now, third slide will let you know how this muscular system is connected to your other important systems of your body. So what are the connection with other system? Other system कौन से आते हैं? We have nervous system, we have respiratory system, we have cardiovascular system. All these systems are connected with your muscular system. How? Consider the first point. Please focus on the first point. Whenever you want to make a particular movement, what do you do first? First of all, your brain will start signal through your nerves, and this signal will then transmit it to your muscles, and then they will do the contraction. And there is a physiological process there, like calcium channels खुलते हैं, calcium वहाँ पर आता है. So that details are not of this class. So simple thing is, whenever you want to do any task, the first signal will come from your brain, and through starting from the nervous and this nerve system, and all nerves will reach your respective muscle. If you want to raise arm, तो आपके brain से signal will go directly to your arms muscles, and then they will cause contraction there and will do the exact amount of force which you require to do particular activity. ज़्यादा जोर लगाना है तो ज़्यादा आपको force मिलेगा, you will have more signal. When you want to relax it, you will get a signal to relax your muscles. So all this system is happening due to your coordination with your nervous system. So nervous system is very crucial when your muscular movements are concerned, because everything you do voluntarily is connected to your brain through nerves, and if there is some problem there, you cannot do that thing efficiently or in a proper way. So the first connection is with your nervous system, because this coordination will allow you to exert exact amount of force in the right direction at right time. And this comes when you do training in sports. How in the sports there are many activities, you are doing skill movements. In sports you have particular techniques which you learn. There are particular techniques which are biomechanically correct. You don't know exact by birth. When you learn biomechanics, you do it correctly right from your starting of your training, and then you get adapted to that. So what is this adaptation? So this adaptation is your brain has been programmed according to the correct techniques. So this is also always considered that when athletes are very young, they should be taught these biomechanical things. अगर आप starting से biomechanically correct way में you will do the movements, so you will adapt to those movements, and that will help you a lot. So biomechanics should be started right at your training part, starting say. So when you are starting training, so that you can have those correct adaptations in your brain कि कौन सा, जैसे for example heel strike नहीं करना है आपने running में, you have to do soft landing, you have to use your SSC stress shortening cycle. अगर ये चीज़ें starting से you impart in your young athletes, so they will get adapted. So adaptation is what? Your coordination with brain get adapted. Yes, we have to do things like that. When you are running, we don't have to strike our heels, because that will do impact on our knees. So ये चीज़ें आपकी जब adapt हो जाती हैं, so that is the connection between your muscular system and your nervous system. Okay. Now, how cardiovascular and respiratory system are involved? The human muscular system also works with these systems. Like supply of oxygen is there, supply of blood is essential, supply of nutrients is essential. So these things will reach only when you have coordination with these cardiovascular system. Cardiovascular system में blood supply होता है, blood में oxygen आपके पास आता है. So if there is perfect coordination, then you will get right amount of oxygen at right time when you require it. Respiratory systems, ये सब system आपके coordination में work करते हैं with your muscular system when you are training, and with training they become more adapted to the skills which you learn. So these are the slide which will let you know the message from this side is that all these systems are connected with your muscular system, and they have to, if you want to perform a particular task in a very efficient way, in a biomechanically correct way. Okay, now fourth slide will tell you the nature of muscles. Basically, what is the nature? Muscle always work in group. No muscle will work individually. Muscles do not work individually. They function in groups to generate efficient movement. For example, जैसे आप curls कर रहे हैं, bicep curls. If you are doing bicep curls, elbow flexors are involved. They are agonists, basically. They are doing the movement. The elbow extensors will do the extension. They are triceps. They will extend. So both of these muscles are agonist and antagonist. They are doing opposite movements, but when they are working in group, they are executing your curl movement, bicep curls. And one of these, if don't work properly, you can't execute this movement properly. You can have injury. So in this way, they always work in groups. Second example is synergistic, जिसमें all the muscles are involved to do a same thing. जैसे you are gripping something, your finger muscle are involved to grip that thing. So muscles always work in a group. To perform a single athletic skill, many muscles work in concert. Example है, just you are want to raise your leg during movement, forward movement, 40 muscles are involved. Simply walking involves 200 skeletal muscles. So you can see these are examples which can clearly show that how large groups of muscles are involved in a particular activities. And सबका coordination कैसे हो रहा है? With your brain. So all things are interconnected to each other. So the message from this side is that all muscles work in a group. Now coming to the types of the muscles. Basically, there are three types of muscles. You can see in front of you. First one are skeletal muscles. Second one are smooth muscles, and third one cardiac muscles. And on the right hand side, this is the microscopic view of all these muscles under the slide. मतलब डायसेक्शन करके स्लाइड के सामने माइक्रोस्कोपिक व्यू आपको दिखाया. So how they look in under the microscope, these three figures. The first one is skeletal muscles, and the top figure which you are seeing is of skeletal muscle in the microscopic view. And these are the muscles which makes 80% of your musculoskeletal system, and these are the muscles which you train, because these muscles have are work according to your will. मतलब यही वो muscles हैं which you can move or allow them to move when you want. That means voluntary control है आपके पास. Whenever you want to raise your arm, you can raise it. Whenever you want to kick a ball, you can kick it. So this is voluntary control. Nobody can stop you. It is you. It is you. Only you can stop it. So this is voluntary control. So these are basically get trained. You're in training, and these are the most important which we'll be dealing with, because these are main importance in the sports, because इन्हीं को आपको train करना है, इन्हीं को आपकी coordination बिठानी है with your brain so that you can execute task perfectly. Second are the smooth muscles. So why they are called smooth? They have some smooth appearance. You can see on the second slide. Okay, and they are involuntary in nature, means you don't have any control over them. These are present in your stomach, these are present in your intestine, and they contract according to their will. You don't have any interference. जैसे आपने खाना खाया, your stomach will get activated, muscles start हो जाएंगे contract होना, उसके बाद intestine काम करेगी, वहाँ पे contraction start हो जाएगी. You cannot do anything because it is not in your control. It is controlled by nervous system automatically, जिसमें आपका कोई control नहीं है. So that is the difference. And then comes cardiac muscles, and these are the muscles which are present in your heart, and these are the muscles which have been reported to work maximum. जितने भी हमारे बॉडी में मसल्स हैं, सबसे ज़्यादा काम work, mechanical work is done by cardiac muscles. They work 24 hours, 365 days, every throughout your life, because they are pumping your blood. So that is the thing. They, if you, it is a question. If I have read somewhere objective type, just for your knowledge, the heart muscle is the muscle which works maximum biomechanically. So this is all about different types of muscles. That much you should know. Now coming to muscle composition. So muscles का composition कैसे है? How they are composed? What is the anatomy basically? So basically, muscles are composed of muscle fibers, and these muscle fibers are also in the group. So just focus on this figure. This is just a brief. On the top, you can see this is a muscle fiber, and this muscle fiber in turn is made up of myofibrils. And when you isolate myofibril from the muscle fiber like this, the below is the enlarged figure of myofibril, and this myofibril you will see those protein filaments like actin filaments and your myosin filaments, and this structure where this arrangement is there is known as sarcomere. तो ये जो Z डिस्क से लेके Z डिस्क तक जो आपको एरिया दिख रहा है, दिस इज नोन एज sarcomere एंड दिस इज द बेसिक फंक्शनल यूनिट ऑफ मसल. जब ये कॉन्ट्रैक्ट होती है तो पूरा मसल अल्टीमेटली कॉन्ट्रैक्ट होगा. ओके, when this get relaxed, whole muscle relaxes. So this is the just a very brief idea. Next slide will make it more clear how they are arranged. यहाँ next slide में आपको more clearly you will get an idea. So because it is starting right from your biceps. So see, just focus on the top. This is your bicep. If you cut it, here the bicep muscle. In the cross section, you can see different bunches. What are these? These are bunches of muscle fascicles. ये देखिए, इसमें से अगर हम एक उठाएंगे, इसको कट करेंगे, इसके अंदर हमारे पास मसल फाइबर्स आएंगे. ग्रुप ऑफ मसल फाइबर्स देयर. एंड व्हेन वी कट द मसल फाइबर, in the inside the muscle fiber we have myofibrils like this. And when we see the myofibril under the great magnification, we'll see the sarcomere. So in short, myofibrils will group together to form muscle fiber will group together to form muscle fascicle, and these will group together to form a muscle. So in this slide it is very clear that there are multiple groups at each level, and they are surrounded by a connective tissue. ये देखिए, हर एक पे कोई ना कोई कवरिंग है, and this connective tissue is variable in different muscles, and this going to affect your mechanical properties of a muscle. So this slides is just a demonstration of anatomy and how different type of connective tissues are there at different levels. यहाँ पर अलग मेम्ब्रेन है, यू कैन सी एज ए मसल. उसके बाद आपको मसल फेसिकल में अलग मेम्ब्रेन मिल रही है एज ए बंच. देन यू कैन सी मसल फाइबर पे अलग मेम्ब्रेन यू कैन सी, and then myofibril. So at each level there is different connective tissue involved, and extent of these tissues, connective tissue, will decide the fate of your mechanical properties of your muscle. In short, connective tissue की जो variability है different muscles में will lead to differences in their mechanical properties. How, we'll let you know in the next slide. Now coming to the muscle biomechanics. So the same thing which I am telling you just now, the amount of connective tissue within a muscle and the size of the connecting tendons may widely from muscle to muscle. So basically connective tissue जो inside मैंने आपको बताया membranes हैं, that will vary, and the arrangement of tendons will vary. So these two arrangements are variable in different muscles of your body. Okay. The amount of connective tissue found in an individual muscle influences the mechanical properties. Keep in mind how mechanical properties are altered by variability in the connective tissue. कहीं पर ये आपको ज़्यादा मिलेगा, किसी मसल में आपको ये कम मिलेगा. Similarly, some muscles have more tendons and are involved connected to muscles, more than one or two. And in some muscles there are only two tendons, or in some muscles there is only one tendon. So depending upon that arrangement of tendons and on the arrangement of connective tissue, mechanical properties of the muscles get varied. Mechanical properties में सबसे पहले क्या आता है? रेंज ऑफ मोशन. कितना रेंज ऑफ मोशन दे अलाउ. So how much force production they allow. So these are the mechanical properties. These will vary according to presence of your connective tissue, number one, and number two, arrangement of your tendons. Now before going further, you should know different types of range of motion we have in the biomechanics. So starting with first one is the simple definition of range of motion. What is range of motion? So it is basically the range through which joint can be moved. कितना आप joint को extend करा सकते हैं या flex करा सकते हैं. So that is your range of motion. So it is usually in the degrees. कि 90 डिग्री तक आप flexion करा सकते हो, 120 तक करा सकते हैं. So it depends upon your range of motion. So this is the basically the range through which joint can be moved. So this range on the is depends on the presence of regional muscles. कौन सा muscle किस joint में involved है, so that will decide the range of a joint. So range of motion is always in the joint, keep in mind, क्योंकि these are the joint where the bone will meet and do the flexion and extension. So this will be decided by muscles, which type of muscle is associated with particular joint, what type of tendons are there, what type of ligaments arrangement is there. So all these factors will decide your range of motion. And basically there are two types of range of motions. One is passive range of motion and second is active range of motion. So what is the difference between the two? Passive range is that when you have relaxed your body and you are lying on a bed and somebody else is doing movements on your joints. वो आपकी लेग को हिला रहे हैं, आपकी लेग को मोशन करवा रहे हैं, and he is doing motion on your applying his force to move your hand, he is applying his force to move your leg. So these kind of motions which you are producing with the help of another person, so that range of motion जो extension and flexion दूसरा person आप में करेगा, that is known as passive range of motion. इसमें because इसमें you are not involved, you are just lying relaxed, whatever force the other person is applying. So this is known as passive range of motion. So what is active range of motion? In which you do the things, you move your leg, you move your arm. So that is active range of motion. So these are the definitions which you should know. What is passive range of motion, what is active range of motion. So these are involved in certain properties when we discuss. Okay. So active versus passive, what is the difference between the two? So next slide will tell you. The passive range of motion is available at joints depending on the shape of articular surfaces. What is shape of articular surface means? The bone ends. At joint, I have told you in the joint chapter that we call bone ends where they match. Joint में जहाँ पर दो bones attach होते हैं, तो वो जो bones के terminal surfaces हैं उनको कहते हैं articular surfaces. So जो उनकी shape होगी, जैसे ball and joint में the bone which is moving is in the shape of ball at the end. Other one is the shoulder girdle is in the shape of joint, but that is fixed one. So ball and so this तरह से जो shape आपकी bones लेते हैं at the end in the joint, so that is known as articular surfaces. So passive range of motion available at joint depends upon the shape of these bone ends or articular surfaces as well as the surrounding soft tissue. Surrounding soft tissue में क्या आएगा आपका? Muscles आ जाएंगे, tendons आ जाएंगे, ligaments आ जाएंगे. Second point, the joint's active ROM range of motion depends upon the muscle ability to pull the limb. So it also depends upon the muscle ability. कितनी उसमें फोर्स प्रोडक्शन का पावर है मसल में, कितना लेंथी मसल है. So that will also decide range of motion of a joint. Active one. Under normal conditions, when everything is normal, you have no injury at all, the active range of motion is almost approximately equal to your passive. Okay. Keep third point in always in your mind that these two, अगर एक joint normally 90 डिग्री तक आपको मूवमेंट करवाता है, रेंज ऑफ मोशन करवाता है, देन अगर कोई दूसरा पर्सन भी उसमें इन्वॉल्व होता है तो वो भी 90 डिग्री तक ही मूव करेगा. सो दैट मीन्स इन नॉर्मल कंडीशन, अदरवाइज देयर इज सम प्रॉब्लम, देन दिस कैन डिक्रीज. ओके. Fourth point, there is a wide variation of in the amount of passive motion available at joint throughout the body. Now there is a variability, you all know, because some muscles involved. For example, जैसे आपका flexion का example दिया fifth point में, knee joint allow you to flexion of up to 140 degrees. On the other hand, the joint at the MCP joint, metacarpophalangeal at your thumb, that will allow not more than 90 degree of flexion. So this is variability depending on the muscles are involved at the joints. So this is all about active or passive. Now we'll come to the biomechanical properties which actual influences your range of motion on the next slide. So basically we are going to discuss in this chapter, in this class, only two properties. The first one is the length of the fibers. length of the muscle fibers which are in your muscles, that will decide your range of motion. Second property is muscle movement arm. So both of these property we'll discuss right now. Okay, so starting with the first property, length of fibers. So effect of fiber length on joint range of motion. How length of a muscle fiber will affect your range of motion at a joint biomechanically. कैसे होगा ये? So basically the fundamental behavior of muscle is shortening, and it is the shortening that produces joint motion. So fundamentally अगर आप देखें, whenever you make a movement, shortening of muscle happen, contraction will happen, muscle will get shortened. Whenever you do movement, जब भी आपने कोई physical movement करनी है, this shortening will happen physiologically, and that will produce a joint motion. Keep this in mind, number one point. Second, the total shortening of the muscle fiber depends on what? Number of sarcomeres. Sarcomeres क्या है, मैंने आपको पहले बताया. These are the basic smallest functional unit of your muscle. So जितनी ज़्यादा sarcomeres आपके मसल में होंगी, the number of sarcomeres present in your muscle will decide the ability of a muscle to contract. जितनी ज़्यादा sarcomeres उतना ज़्यादा contraction का capability. More the sarcomeres in the muscle, more is the ability to contract, and lengthier will be the fiber. So please consider on the third point, the more sarcomeres in the fiber, the longer the fiber is, muscle fiber, and more shortening it can do. So all is related to sarcomere. So the first one is joint. तो जितना ज़्यादा आपका muscles में sarcomeres होगा muscle fiber में, the more the muscle fiber sarcomeres in your muscle fiber, the lengthier it will be. और जितना लंबा होगा मसल, उतना ज़्यादा वो शॉर्टनिंग कर सकता है, बिकॉज सारी मसल सार्कोमेयर्स कॉन्ट्रैक्ट करेंगी तो ज़्यादा कॉन्ट्रैक्शन होगी, एंड उतना ज़्यादा वो रेंज ऑफ मोशन प्रोड्यूस करेगा. जस्ट कंसिडर ऑन द these two muscles. On the left hand side you can see how many sarcomeres are there. 1 2 3 4, 4 are visible. So जब 4 sarcomeres हैं, that automatically tell you that A is longer in length as compared to B. B में आपके कितनी sarcomeres है? सिर्फ 2. Now when the 4 will contract, they will shorten more. तो इसमें contraction ज़्यादा होगी as compared to B. So which muscle will produce more range of motion, A or B? So definitely A will produce more joint range of motion, because here we have more number of sarcomeres. When you have more number of sarcomeres, that means you have longer muscle fibers, and when you have longer muscle fibers, they have more ability to contract, and when they contract more, they will produce more motion, रेंज ऑफ मोशन. सो जहाँ पर आपका रेंज ऑफ मोशन ज़्यादा है, जैसे आपके शोल्डर जॉइंट में बहुत ज़्यादा रेंज ऑफ मोशन है, नीज में बहुत ज़्यादा है, वहाँ पर मसल फाइबर्स विल बी लॉन्गर. सो दिस इज द मैकेनिक्स बिहाइंड फाइबर लेंथ एंड जॉइंट रेंज ऑफ मोशन. नाउ कंसीडर मसल एज ए होल. अभी आप तो अपने मसल फाइबर्स का बताया, तो मसल भी वैसे बिहेव करेंगे. हाउ मसल एज ए होल विल बिहेव on based on this principle. So the amount of whole muscle can shorten is dictated by length of his muscle fibers, and muscle fiber length is dependent upon number of sarcomeres. So simply relation is, if you have more number of sarcomeres, that means you have longer muscle fibers, and when you have longer muscle fibers, that means you have longer muscles. So this is a clear connection between the two. Second point, however, there is a wide variation in fiber lengths. Now coming to the second point, in the human body, ranging from a few centimeters and approximately half a meter. Now these muscle length, the fiber length, जो length है आपके muscle fiber की, it is variable in our body. In some parts it is just a few centimeters, and in some parts it is even in the half a meter range. So इतनी variability है हमारे muscle fibers में. So what is the factor which decide this, कि कहाँ पर आपका long muscle चाहिए, कहाँ पर आपका छोटा muscle चाहिए. The second now point is coming into the play. So that is architecture of muscles. Architecture is arrangement of your muscle fibers. किस तरह से वो arranged in your muscles, that will also decide the muscle length, muscle fiber length. So the first property we have already discussed is your length of fiber, length of muscle fiber. That will define your range of motion. Now coming to the second point, how it is decided that some longer muscle will have longer muscle fibers. There is an additional point involved is the architecture of muscle. Architecture क्या है? Arrangement of muscle fibers, how they are arranged, how tendons are connected, how ligaments are connected. This geometry, this arrangement will also affect the arrangement of your muscle and length of the muscle. Now we are going to discuss this architecture of skeletal muscles, क्योंकि on the basis of this architecture muscle length will be decided. So the arrangement of muscle fiber is known as architecture of skeletal muscle. Okay. So this fiber arrangement has a marked effects on muscle ability to produce movement and generate force. And basically these are of two types: parallel arrangement and pennant arrangement. So muscle fibers are arranged in the two ways. One is parallel and one is pennant. And depending upon this arrangement, different muscles produces different kind of movements and different amount of force they generate. Now we'll discuss parallel versus pennant. So what is parallel arrangement? So the parallel arrangement is basically, in parallel arrangement, the fibers within the parallel fiber muscles are approximately parallel to the length of whole muscle. Point one. तो फर्स्ट अरेंजमेंट क्या होगा, इसमें मसल फाइबर्स ऑलमोस्ट पैरेलल होंगे, सीधे होंगे, मसल के साथ पैरेलल होंगे, दे वोंट बी एंगल्ड और समथिंग लाइक दैट. So first property of parallel arrangement is they will be parallel to the muscle length. Second point, basically there are two types, subtypes है इसमें, इसको हम बोलते हैं fusiform और strap muscles. These are subtypes of parallel arrangements. Now third, इनमें difference क्या है fusiform और strap. Third point will define the tendons. In parallel arrangement there are always two tendons are involved at both the ends. Keep in mind, parallel arrangement में हमेशा दो tendon से ज़्यादा आपको नहीं दिखेंगे. So the fusiform muscles have tendons at both the ends and they are very clearly visible. On the other hand, जो strap muscles हैं वहाँ पर tendons तो रहते हैं but they are not visible very clearly, but they are there. So the message here is, in parallel arrangement muscle fibers are arranged parallel to the muscle length. Number two, they have tendons at both the ends. Depending upon the way they look, if they are very clearly there, then we call it fusiform muscles. When they are not visible clearly, then we call it strap muscles. And the fibers are relatively longer in this arrangement. So the parallel arrangement जब आपको दिखेगा तो definitely it means that muscle fibers are going to be lengthier, and when they are lengthier means they have more sarcomeres, and when they have more sarcomeres that means they can contract more and can produce more range of motion. So this is all about parallel, and this is a figure which is example of both types. Strap muscle, the left side is the strap muscle, right side is your fusiform in the biceps. So this is examples of parallel arrangement. Now coming to the pennant arrangement. Let the slides change on your screens. Yeah. So pennant arrangement क्या है? In pennant arrangement, a pennant muscle has one or more tendons. This is the main difference. यहाँ पर आपको tendons ज़्यादा मिलेंगे. That extend most of the length of the whole muscle. They are extended throughout the muscle. And fiber जो है इसमें parallel arrangement नहीं होता, oblique. They are angled. The arrangement of fibers is oblique. Third point, pennant muscle fall into subcategories. इसमें भी subcategories हैं depending on the number of tendons. If there is one tendon involved, we call it unipennate muscle. When there are two tendons are connected, we call it bipennate. And when there are more than two, we call it multipennate muscles. And these are relatively shorter, or जब they are shorter that means they have less number of sarcomeres, and they are, when there are less number of sarcomeres means their ability to contract is less. So this is the second arrangement, pennant arrangement. And here are the example, where you can see unipennate in the your hand, and then you can see bipennate in the elbow, and on the griddle, shoulder griddle, you can see the multipennate. So these are the example of different pennant muscle arrangements. So the muscle with, now the summary of this arrangement, the muscle with parallel fibers has longer fibers than those in the pennant muscles, right? Second point, the muscle with parallel fiber is able to shorten more than the pennant muscle because they have more sarcomeres. And this will differentiate and summarize the whole picture in front of you. On the left hand side, you can see the parallel arrangement, and please focus on the red, that is the muscle fiber, and see it is relatively longer. On the right hand side you will see the oblique muscle fiber, and on the right hand side this is pennant arrangement. So on the left side the muscle, you can see the difference between the both muscle fibers. Now, second point, movement arm, muscle movement arm, how it is going to affect. So what is muscle movement arm? Muscle movement arm is basically a perpendicular distance between the muscle and the point of rotation of joint, or you can say that it is the distance between the muscle and the line of force, line of acting force. In the figure you can see the dotted line, that dotted line is your muscle movement arm. So that will actually going to produce torque on this, and that will create a joint rotation. So this movement arm depends upon the location of the muscle attachment on the bone, and second it depends on the angle. So in जो rotation होनी है आपकी, the theta angle, it is known as angle of application. So this distance will depend upon sine theta of this angle, and secondly the distance between the point of rotation and the muscle. So this is known as moment arm. Now how it is going to affect your motion, or how it is going to affect your biomechanics, next slide will make it clear. So in simple words, if I say what is movement arm, it is simply the length between the joint axis and the line of force, the same thing which I have told you in the earlier slide. So now you focus on these two exercises, you will that will let you know. Now the black dotted line is your line of force. Okay, so this is a back squat exercise. Now you can see the two movements here. On the green this is hip movement, hip movement arm. यहाँ पे hip muscle है, glutes है, that is green, and this is the perpendicular distance from the line of action. ठीक है, यहाँ पर joint है आपका hip joint. So this is your hip muscle arm movement, and on the right hand side the blue one is your knee movement arm. Now in this diagram you can clearly see कौन सा ज़्यादा है, the green one. So that what means biomechanically that hip muscles are working more in this particular workout, because the movement is more towards this side as compared to knee. So when back squat, when you are performing back squat, so the muscles which are involved are working more. The ones which are more working are at number one is your hip movement arm, that is your hip muscles. Second one are your no knee, and this is happening because he is doing perfect posture. If he's not doing in a biomechanically correct way, he's not doing proper bending and all that, then he will provide unnecessary stress on his knees. तब ये बढ़ जाएगा, and that can cause injuries, because glute muscles are strong enough to handle these kind of stresses, while knee muscles are not. So he is doing in a perfectly correct way. See, his spine is perfectly angled, and perfect flexion is there. So that's why his more stress is giving more stress on the hip joints, and that is a perfect biomechanical posture. On the right hand side, when you do front squat, then you keep your arms like in the front, and in this you can see clearly that both movements are almost equal and both muscles are involved equally. So in this way these kind of movement help you to see that you can see which variation can produce more stress on which muscle. Understanding these movement arms will enable you to determine which variations are safe or which are dangerous, and what muscles are working at most and which muscle is working least. So in this way you can pinpoint your biomechanics of muscle, which is involved, which is not involved, and accordingly you can modify. And if some mistake is there, you can correct that biomechanically. So this is the advantage of studying all these biomechanical principles in relation to mechanics. So this is all about chapter 1, part A of, you can say, of muscle biomechanics. In the next chapter, in the next class, we'll dealing with the muscle strength, biomechanics of muscle strength, how mechanical factors will alter your muscle strength biomechanically. So that's it for today. Thank you very much. Please like the video for the welfare of channel. Please.